Hi, in the last video I showed you how to calculate the dependent sample's t-value, and in this video we're going to do an interpretation of the dependent sample's t-value. It's very similar to how we interpret an independent sample's t-value. The major difference, of course, is that we need to calculate the degrees of freedom slightly differently. So we'll walk through it, however, relatively quickly here. Okay, to catch you up, if you missed the last video, we had an independent variable which was smoking cessation. We had a dependent samples design, meaning we were measuring, in this case, the same people at two different time periods. One was before the intervention, which was a hypnosis session, and one was after the session. And our dependent variable was how many cigarettes they smoked. Exactly. So we ended up at a t-value of 2.58, meaning that overall they smoked fewer cigarettes at the second time that we measured them compared to the first. We had 8 pairs of observations, or in other words, we had 8 difference scores, differences between time 1 and time 2. So in other words, 8 people were measured twice, and therefore we had 8 paired observations of the dependent variable. Our null hypothesis was that the mean difference would be 0. You recall that. I walked through that in the previous video if you aren't sure what that means. And our alternative hypothesis in this case was that we would get a mean larger than 0, a mean difference larger than 0, because we expected a larger mean at time 1 than time 2. Because we specified the direction of our mean difference in this alternative hypothesis, that means that we're using the one-tailed test criterion. So again, I'll walk you through that just briefly, but if you're not sure about that, I have a previous video that explains the one-tail versus two-tail criteria. Okay, so once again, we have a dependent samples t-test. We need to first calculate the degrees of freedom once we have our t-value already, which we already do. Now, with a dependent samples t-test, you actually take the number of different scores that you have, or the number of paired observations, you could also call it, and then you subtract 1 from that, okay? So again, in this case, because we had 8 paired observations, or 8 different scores, 8 minus 1 is, of course, 7. So we have 7 degrees of freedom in this particular case. All right. Now what we do with that is we look up Appendix B if you're using my textbook. But again, if you're not using my textbook, you can just Google any kind of t-distribution, anything like that. It's the same t-distribution that you would use for the independent samples t-test and also for a one-sample t-test. So they're all the same. Okay, and of course here is Appendix B from my textbook. Once again, we've got the two-tailed criteria over here, the one-tailed criteria over here. As I specified, we're interested only in the one-tailed criteria because we have already specified that we thought mean 1 would be bigger than mean 2, and we left no possibility for the opposite to occur. If we left it open to both possibilities, then we would use the two-tailed criteria. But we are interested only in the one-tailed criteria. And again, we're interested in only the degrees of freedom of 7, so we're looking only at degrees of freedom equals 7 down in this row and only on this right side. And then over here on the right side, we're interested only in the p level or the alpha level or the chance of committing a type 1 error of 5%. Okay, so in other words, if we reject the null hypothesis, we want to leave it only to a 5% chance that we're making a mistake, which is by definition a type 1 error. So what this is telling us is that we need to look at the criteria right here, the criterion right here. We can use these if our obtained t-value exceeds these values. That's fine. That means there's even a lower chance we're committing a type 1 error by rejecting the null hypothesis. But we start off with 0.05. So let me zoom in on that. So here's this. I've just moved the degrees of freedom over here so that you can see how it lines up. Once again, if we have 7 degrees of freedom, that means that we have, and we're interested in the 5% level of type 1 error. That means that we need to have gotten a t-value of at least 1.895, equal to or greater than 1.895 to say that we found statistical significance, and to allow us to reject that null hypothesis and say any difference we found probably is due to our intervention, in this case our hypnosis. Okay? Now, just if we had assumed one-tailed test criterion except we thought that mean 2 would be bigger than mean 1, we would have specified that we expected a negative value. And then all we do is look for that negative sign there to then indicate that we found statistical significance. But again, in this case, we did expect a positive value as I specified in that alternative hypothesis a few slides earlier. Now let's take a look at a t-distribution to see how this works. Okay, so again, here's a t-distribution, a distribution of t-values of tests with the same test criterion of 7 degrees of freedom, right? If we had done this same test a million times, we probably would have gotten a distribution about like this. This is what we would have expected anyway. And what we're saying is, if the independent variable had no effect on the dependent variable, we would expect to get a t-value of 1.895 or larger no more than 5% of the time, okay? So this is what we're interested in. If we get a t-value that falls into this realm, including 1.95, that's interesting to us. In other words, if we have a test with 7 degrees of freedom, a dependent samples t-test with 7 degrees of freedom, we're looking for a t-value of 1.895 or greater to say that it's statistically significant. And of course, we did find that it is statistically significant because our t-value we obtained using our data was 2.58. And 2.58 falls deeper into this tail of interesting t-values than 1.895. So therefore, we found statistical significance. Okay, so just to wrap this up, we found a meaningful difference in the number of cigarettes that was smoked between time 1 and 2. Specifically, we found that there was a larger number of cigarettes smoked before the intervention compared to after the intervention, meaning it seems that our best guess for the reason why we had a reduction in the number of cigarettes smoked is because of our intervention of the hypnosis. So it looks like our hypnosis worked. We should probably recommend this and move on to using larger samples, for example, and controlling for other variables as well, but that's good. And we can reject it now with less than a 5% chance of making a mistake. And in this case, if we're rejecting the null hypothesis, that means we would be potentially making the mistake of a type 1 error. But now we have a less than 5% chance of committing a type 1 error. That's what statistical significance means. We can also specify this specifically. You can sort of summarize it in APA format in this way. A t-value of 7 degrees of freedom was 2.58. That was our t-value, and we have less than a 5% probability of committing a type 1 error by rejecting the null hypothesis. Okay, now this is also a large enough difference. This is all wrapped up in statistical significance that it looks like our independent variable was the thing making the difference on the dependent variable. Okay, that's how we interpret that. Now, of course, with a t-value, we also can calculate a measure of effect size, and we should also calculate measures of confidence or a confidence interval. Now, we'll do that in the next video. I'll combine that because we already did that for the independent samples t-test. And so now it'll, of course, be important to see how this works for a dependent samples t-test. It's slightly different, but the same idea. I will see you then.